Numericals of cross product. Numericals of cross product. So first we can recollect what are the formulas we have studied. Okay, cross product. So number one, A vector cross B vector. So what is the formula? AB sin theta into n cap. Okay, AB sin theta into n cap. Or we can write A vector cross B vector is equal to modulus of A vector modulus of B vector into sin theta into n cap. Second formula. What is modulus of A vector cross B vector is equal to modulus of A vector modulus of B vector into sin theta. Okay. So what is the sine of the angle between two vectors? So sin theta is equal to, so from this sin theta is equal to, so modulus of A vector cross B vector divided by modulus of A vector into modulus of B vector. So what is the formula to find the unit vector? Okay, unit vector perpendicular to A vector and B vector. Okay, so from this expression, that is n cap is equal to A vector cross B vector divided by modulus of A vector cross B vector. So this is a formula to find the unit vector perpendicular to A vector and B vector. Fifth formula. If two vectors are parallel or anti-parallel, okay, anti-parallel, that is cross product is equal to 0. A vector cross B vector is equal to 0. The next formula, if the vector is in rectangular component form, for example, A vector is equal to AX I cap plus AY J cap plus AZ K cap. Okay? And B vector is equal to BX I cap plus BY J cap plus BZ K cap. Okay, so what is the formula? That is A vector cross B vector is equal to determinant of I cap, J cap, K cap, AX, AY, AZ, BX, BY, BZ. Okay, this is the formula to find A vector cross B vector. Okay, so these are the formula you have to keep in mind while solving, that is cross product of vectors. Okay, cross product. Clear? So first problem is question number 1. So I will read the question. Prove that the vectors A vector is equal to 2i cap minus 3j cap minus k cap, and b vector is equal to minus 6i cap plus 9j cap plus 3k cap are parallel. Okay, parallel. So we have to prove that these two vectors, a vector is equal to 2i cap minus 3j cap minus k cap, and b vector is equal to minus 6i cap plus 9j cap plus 3k are parallel. So if two vectors are parallel means we have to show that is a vector cross b vector is equal to 0. We have to prove that. Okay, we have to show that a vector cross b vector is equal to 0 means the vectors are parallel. Okay, so the vectors are given in the rectangular component form. So what is the formula to find? That is a vector cross b vector is equal to determinant of I cap, j cap, then k cap. So the coefficient of I 2, minus 3, minus 1. Coefficient of b vector, that is minus 6, 9, 3. Okay. So how to expand the determinant? First I cap into. So cut this column and this column. Okay. Cut this column and this column. So what is remaining? 3 into minus 3. So minus 9 plus 9 into minus 1. Okay, 9 into minus 1. So minus 9. Then minus into. So actually the sign will come, that is the second sign minus. Okay, minus 9 into minus 1. Minus 9. So minus into minus plus. So plus 9. Okay. Then next sign. Minus j cap. Okay, minus j cap. So next minus. Okay, minus. So cut this row and this column. Cut this row and this column. So what is remaining? 2 into 3. 6. Minus. Minus into minus plus. 6 into 1. 6. Then next sign plus. K cap. K cap into. So cut this column and this row. Okay. This row and this column. So what is remaining? 9 into 2. 18. Minus. Minus into minus plus. 6 3s are 18. Okay, 18. So minus 9 plus 9. That is 0. Minus the 6 minus 6. That is 0. 18 minus 18. That is 0. So that's equal to 0 I cap minus 0 j cap plus 0 k cap. That's equal to 0 vector. That is null vector. Okay, null vector. So a vector cross b vector is equal to 0. Therefore we can say that these two vectors, a vector and b vector, is equal to. So we have studied if two vectors are parallel and anti-parallel. Okay, anti-parallel means the cross product is equal to 0. So we get the cross product is equal to 0. So therefore we can say that a vector and b vector are parallel. Okay. Then second question. Calculate the area of the parallelogram. Calculate the area of the parallelogram. Calculate the area of the parallelogram. Parallelogram whose adjacent sides are formed by the formed by the vectors. A vector is equal to 3i cap plus 4j cap and B vector is equal to minus 3i cap plus 7j cap. So we have to find the area of the parallelogram. So the parallelogram, so in the parallelogram the two sides are formed by these two vectors, that is two adjacent sides. So what is a parallelogram? Okay, it's a parallelogram. Okay, so two adjacent sides are formed by this, that is, this is O, A, B, then C. Okay, C. Two adjacent sides, that is, this is A vector. A vector is equal to, that is 3i cap plus 4j cap. And B vector, this is B vector, okay, this side, B vector is equal to minus 3i cap plus 7j cap. Okay. So we have studied, that is, the suppose two vectors, the adjacent sides of the parallelogram is formed by two vectors, means what is the area of the parallelogram? That is the cross product of the vectors. Okay, cross product, that is the magnitude of the cross product, A cross B is equal to, we have studied, that is area of the parallelogram. Area of the parallelogram. So first we have to find A vector cross B vector. So the vectors are given in the rectangular component form, that is determinant I cap, J cap, K cap. Okay, K cap. So coefficient of I 3, 4. What is K? Coefficient of K, that is 0. So minus 3, 7, that is the component of B vector. Okay, minus 3, 7, then K component is 0. Okay, so that's equal to I cap into, so cut this column and this row. So 4 into 0, 0, minus 7 into 0, that is 0, minus J cap into, so cut this column and this row. So what is remaining? 3 into 0, 0, minus 3 into 0, that is also 0. Then plus K cap into, so cut this column and this row and this column. 7 3s are 21, minus, okay, minus 4 3s are 4 into minus 3, that is minus 12. So minus into minus, plus, so 12. Okay. So that's equal to 0 I cap, 0 j cap. Okay, 0 j cap. So what is remaining? That is 21 plus 2, that is 33. 33 K cap. 33 K cap. So what is this? Is A cross B, A vector cross B vector. So we have to find, that is modulus of A vector cross B vector is equal to area of the parallelogram. So modulus of A vector cross B vector. Okay, B vector. So what we have to take, that is the root of, okay, root of, that is 33 square. Okay, 33 square. If the vector is given, that is, if the vector is like this, that is A vector is equal to AX I cap plus AY J cap plus AZ K cap. So what is the modulus of A vector? What is the modulus of A vector? A vector is equal to square root of, this is a formula, square root of AX square plus AY square plus AZ z square. Okay, this is the modulus. So here only k component is there. I component and j component is 0. Only k component. So modulus of a vector plus b vector is equal to root of 33 square. So that's equal to 33 square units. Clear? So third question. Determine a unit vector or find the unit vector. Find the unit vector perpendicular to both a vector is equal to 2i cap plus j cap plus k cap, and b vector is equal to I cap minus j cap plus 2k cap. So find the unit vector perpendicular to both a vector and b vector, that is I cap minus j cap and 2k cap. So what is the formula to find the unit vector? Unit vector, that is n cap is equal to a vector cross b vector divided by modulus of a vector cross b vector. Modulus of a vector cross b vector. Okay. First, a vector cross b vector is equal to determinant of I cap, j cap, k cap. Okay. So 2, 1, 1, 1, minus 1, 2. Okay. That's equal to I cap into. So cut this column, this row. 1 into 2, 2, minus 1 into minus 1, minus 1, minus into minus plus 1 into 1, minus j cap into. Cut this column and this row. 2 into 2, 4, minus 1 into 1, 1, plus k cap into. Cut this column, this row. 2 into minus 1, minus 2, minus 1 into 1. So that's equal to 2 plus 1, 3. 3 I cap. 4 minus 1, 3. Minus 3 j cap. Minus 2 minus 1, minus 3. Minus 3 k cap. So this is a vector cross b vector. Okay, a vector cross b vector. So next we have to find, that is modulus of a vector cross b vector is equal to, what is the formula? Square root of ith component, that is coefficient of I, that is 3 square, plus coefficient of j minus 3 square, plus coefficient of k minus 3 whole square. So that's equal to square root of 9 plus 9 plus 9 equal to so that's equal to take 9 commonly outside, square root of 9 into, that is 1 plus 1 plus 1. Okay, so square root of 9, that is 3, root 1 plus 1 plus 1, that is 3 root 3. That is modulus of A vector cross B vector. Now we can find unit vector. N cap is equal to A vector cross B vector. A vector cross B vector what? That is 3i cap minus 3j cap minus 3k cap. Okay, so divided by 3 root 3 is 3 root 3. So from this take 3 commonly outside. I cap minus j cap minus k cap divided by 3 root 3. So 3 get cancelled. So that's equal to 1 divided by root 3 into I cap minus j cap minus k cap. So this is the unit vector perpendicular to, that is A vector and B vector. Clear? Fourth question. Determine the angle between the vectors. Determine the find the angle between the vectors. Angle between the vectors. 3i cap plus j cap plus 2k cap and 2i cap minus 2j cap plus 4k cap. So we have to find the angle between these two vectors, that is 3i cap plus j cap plus 2k cap. So we can take, that is first vector A vector is equal to 3i cap plus j cap plus 2k cap. B vector is equal to 2i cap minus 2j cap plus 4k cap. So sin of the angle between these two vectors, what is the formula? That is sin theta is equal to modulus of A vector cross B vector divided by mod A vector mod B vector. This is a formula to find the sin of the angle between two vectors. Acha. Then so we can find, that is A vector mod A vector. First we have to find mod A vector is equal to root of 3 square plus 1 square plus 2 square. So that's equal to square root of 9 plus 1 plus 4. So that's equal to root of 14. So modulus of B vector is equal to square root of, that is 2 square minus 2 the whole square plus 4 square. That's equal to square root of 4 plus 16. So that's equal to root of 24. Okay, 24. Next we have to find, that is A vector cross B vector. Okay, A vector cross B vector is equal to determinant I cap, j cap, k cap. Okay, I cap, j cap, k cap. So first A vector, that is 3, coefficient 3, 1, 2, coefficient of B vector, that is 2, 2, minus 2, 4. Okay, 4. So expand the determinant I cap into, so cut this column, this row. So 1 into 4, 4, 2 into minus 2, minus 4, minus into minus, plus 4, minus j cap. So cut this column, this row. Okay, this row. So what is remaining? 3 4s are 12. 3 4s are 12. 2 into 2, 4. 4 minus 4 plus k cap into, cut this column and this row. 3 into minus 2, minus 6, minus 2 into 1, minus 2. Okay, so that's equal to 4, 8, I cap, 12 minus 4, 8, minus 8, j cap, minus 6 minus 2, minus 8, k cap. Okay, so this is A vector cross B vector. So we have to find mod A vector cross B vector is equal to square root of 8 square plus minus 8 square plus minus 8 square. So that's equal to root of 64 plus 64 plus 64. So take 64 commonly outside. So root of 64 into 1 plus 1 plus 1. So what is square root of 64? 8. 8 root 3 is the answer. That is mod A vector cross B vector. Now next, now we can find sin theta. Sin theta is equal to mod A vector cross B vector, that is 8 root 3 divided by mod A vector, that is root 14, into mod B vector, that is root 24. Root 24. So that's equal to 8 root 3 divided by root 7 into root 2. I am writing that is root 14. I am writing that is root 7 into root 2 into root 8 into root 3. Okay, I am writing that is root 24 is equal to root 18 into root 3. Okay, so this root 3 cancel. Okay, root 3 cancel. So we can write this 8 square root of 8 into square root of 8. Okay, root 7 into root 2 into root 8. Okay, so this root 8 cancel. So root 8 we can write that is 2 root 2. Am I right? 2 root 2 divided by, in the denominator, root 7 into root 2. So this root 2 cancel. So that's equal to 2 by root 7. Okay, 2 by root 7. So sin theta is equal to 2 by root 7. Therefore theta is equal to, this is sin theta. Sin theta. So we have to find the angle between. So theta is equal to sin inverse of 2 by root 7. So this is the answer. Clear? So fifth question. Find the area of the triangle. Find the area of the triangle. Find the area of the triangle formed by the tips of the vectors. Formed by the tips of vectors. A vector is equal to I cap minus j cap minus 3k cap. B vector is equal to 4i cap minus 3j cap plus k cap, and C vector is equal to 3i cap minus j cap plus 2k. So consider a triangle. This is A, B and C. These 3 points. Okay. And C is given with in the rectangular components. These 3 points, point A, point B and point C, are given in the form of vectors. Okay, in the form of vectors. So point is given means rectangular components means that is this point. Okay, so this point is at a distance of from the origin. Okay, from the origin. B point is at a distance of from the origin. C point is at a distance of from the origin. Okay, so that means this OA vector. Okay, OA vector is given. Okay, OA vector is equal to I cap minus j cap minus 3k cap. OB vector is also given. OB vector is equal to 4i cap minus 3j cap plus k cap. OC vector. Okay, OC vector 3i cap minus j cap plus 2k cap. So we want to find the area of the triangle by getting this one of the sides, that is AB vector, and another side of the triangle as AC vector we have to find. Okay, AC vector. So we know the formula, that is what? Cross product of modulus of the cross product. Okay, modulus of the cross product. Magnitude of the cross product. A vector cross B vector is equal to 2 times of, okay, 2 into area of the triangle. Area of the triangle formed by the 2 vectors. Okay, formed by the 2 sides of the adjacent triangles. Okay, formed by the 2 vectors as the adjacent sides of the 2 triangles. This side and this side. Suppose A vector is making, okay, A vector is the side of this triangle, this side, and B vector is forming this sides. Okay, forming this side means the magnitude of A vector cross B vector is equal to 2 into area of the triangle, formed by the vectors A vector and B vector as its adjacent sides. different signs. But in the question it is given, that is not A vector and B vector is not given. Okay, the side vectors are not given. So it is given, that is OA vector is given, that is the distance of the point A from the origin is given, that is OA vector. OB vector is given, distance of the point B from the origin is given. Distance of the point C from the origin is given. So we have to find, that is what? AB vector we have to find, AB vector. So AB vector is equal to, what is the formula? That is OB vector minus OA vector. Okay, OA vector. So that's equal to OB vector, that is 4i cap minus 3j cap plus k cap minus OA vector, that is I cap minus j cap minus 3k cap. So that's equal to 4 minus 1, that is 3, 3i cap minus 3 minus 1, that is minus 4, minus 4 j cap, then 1, so that's equal to 4i cap minus 3j cap plus k cap minus I cap plus j cap plus 3k cap. So that's equal to 4i minus I, that is 3i cap, minus 3 plus 1, that is minus 2, minus 2j cap, then 1 plus 3, that is 4, that is 4k cap, right? So similarly AC vector also we have to find, that is AC vector is equal to, what's the formula? OC vector minus OA vector. So that's equal to, what is OC vector? 3i cap minus j cap plus 2k cap minus of OA vector, that is I cap minus j cap minus 3k cap. So that's equal to 3i cap minus j cap plus 2k cap minus I plus j plus 3k. So that's equal to 3 minus 1, that is 2 I cap minus j plus j, that is 0 j cap plus 2k plus 3k, that is 5k cap. So this is AC vector. So now we got, that is this side of the triangle AB vector, and another side of the triangle, this is AC vector. Okay. So the modulus of these two vectors equal to, that is AB vector cross AC vector is equal to 2 into area of the triangle. Am I right? Area of the triangle. So therefore area of the triangle is equal to 1 by 2 into modulus of AB vector cross AC vector, right? So this is AB vector, okay, AB vector. 3i cap minus 2j cap and 4k cap, okay, 4k cap. So we have to find modulus of first we have to find, that is AB vector cross AC vector is equal to determinant of I cap, J cap, K cap. Okay. AB vector, that is 3, minus 2, 4. What is AC vector? That is 2, 0, 5. So that's equal to I cap into, cut this column, this row, 2 minus 2 into 5, minus 10, minus 0, plus J cap into, cut this column and this row, 3 5 3s are 15, minus 8, plus K cap into, cut this column and this row, 3 into 0, 0, minus into minus, plus, that is 4. So that's equal to minus 10 I cap, 15 minus 8, 8, plus 8 J cap, plus 4 K cap. Okay, 4 K cap. So what is modulus of AB vector cross AC vector is equal to square root of minus 10 square plus 8 square plus 4 square. So that's equal to 100 plus 64 plus 16. So that's equal to square root of so that's equal to 180, square root of 180, modulus of A vector cross AC vector. Sorry, here 15 minus 8, that is 7. Okay, 7 J vector. So 7 square. Okay. So that's equal to root of 100 plus 49 plus 60. Okay, 49 plus 60. Hundred plus 149, 159, 165. Square root of 165. 49, 59, 60. Okay, 65, 165. That is modulus of A vector cross AC vector. So now we have to find, that is area of the triangle is equal to 1 by 2 into, okay, 1 by 2 into. So what is square root of 165? That's equal to 12.8. Okay, 12.8. So therefore, area of the triangle is equal to 1 by 2 into root 1 by 2 into modulus of AB vector cross AC vector. So that's equal to 1 by 2 into root of 165, that is 12.8. Okay, 12.8. So 6.4. Okay, 6.4. 6.4 square units is the answer. Okay, 6.4, that's equal to 6.4 square units. So question number 6. So for any 3 vectors, okay, write down the question. For any 3 vectors, A vector, B vector, and C vector, prove that A vector cross B vector plus C vector plus B vector cross C vector plus A vector plus C vector cross A vector plus B vector. A vector cross B vector is equal to 0. So what is given, that is we have to prove, that is for any 3 vectors, A vector, B vector and C vector, we have to show that A vector cross B vector plus C vector plus B vector into C vector plus A vector plus C vector into A vector cross B vector. Okay, so A vector plus B, so here plus, is equal to 0 we have to prove. So LHS, what is given, that is A vector cross B vector plus C vector plus B vector into C vector plus A vector plus C vector cross A vector plus B vector. So that's equal to, that is vector product is a distributive over addition. Okay, so that principle, that is A vector cross B vector plus A vector cross C vector, then this plus here B vector cross C vector plus B vector cross A vector, then this plus C vector cross A vector plus C vector cross B vector. So A vector cross B vector plus A vector cross C vector plus B vector cross C vector. So this B vector cross A vector, so we can write B vector cross A vector is equal to, so we have studied, that is A vector cross B vector is equal to B vector cross A vector, the negative of, that is anti-commutative, okay, by the principle of anti-commutative law. A vector cross B vector is equal to minus B vector cross A vector. Okay, so by that principle we can write, that is B vector cross A vector, we can write that minus of A vector cross B vector. So plus this also, by the principle of anti-commutative law, we can write minus of A vector cross C vector plus this also minus of B vector cross C vector. So A vector cross B vector minus A vector cross B vector cancel. A vector cross C vector minus A vector cross C vector cancel. B vector cross C vector minus B vector C cancel. So that's equal to what? 0. Clear? It's a proof. Seventh question. So for any two vectors, for any two vectors, A vector and B vector, A vector and B vector, prove that A vector cross B vector the whole square is equal to A square B square minus A vector dot B vector the whole square. So what is the given? For any two vectors, A vector and B vectors, prove that A vector cross B vector the whole square is equal to A square B square minus A vector dot B vector the whole square. We have to prove. Okay. So how we can prove that? So we have to prove that is LHS. I am taking LHS equal to A vector cross B vector the whole square. So we have to prove that is RHS. Okay, RHS, right hand side. So this I can write that is A vector cross B vector is equal to, we can write that is modulus of A vector cross B vector the square we can write. Okay, this is nothing but that is modulus of A vector cross B vector is equal to A vector cross B vector. Okay, that's equal to, what is A vector cross B vector? Modulus of A vector cross B vector, that is A vector cross B vector is equal to A vector cross B vector is equal to AB sin theta into n cap. So when we take the modulus, so it will disappear, that is the unit vector will disappear. So we can write that is AB sin theta square. Okay, AB sin theta square. So that's equal to A square B square sin square theta. Am I right? A square B square sin square theta. So that's equal to A square B square sin square theta. I can write that is 1 minus cos square theta. Okay, because sin square theta plus cos square theta is equal to 1. So sin square theta, from this sin square theta is equal to 1 minus cos square theta. So that's equal to A square B square. Okay, B square. So what I am doing, that is I am multiplying this A square B square inside. Okay, inside the bracket. So that's equal to 1 into A square B square. So A square B square. Okay, minus A square B square cos square theta. Okay, cos square theta. So that's equal to A square B square minus A square B square cos square theta. I am writing that is AB cos theta the whole square. Okay, A square AB cos theta the whole square. Okay, so what is A vector dot B vector? A vector dot B vector is equal to modulus of A vector modulus of B vector cos theta. Okay, cos theta. So that's equal to modulus of A vector, that is A, modulus of B vector, that is B, cos theta. So here AB cos theta, AB cos theta. AB cos theta is nothing but A vector dot B vector. Am I right? So that's equal to A square B square minus A vector dot B vector square. So this is we have to prove, that is A square B square minus A vector dot B vector the whole square. Hence the proof. ठीक है? So the next question, Eighth question. Eighth question. Prove that A vector plus B vector cross A vector minus B vector is equal to 2 times of B vector cross A vector. So suppose A and B are two vectors. Okay, A and B are two vectors. What we have to prove? A vector plus B vector cross A vector minus B vector is equal to 2 times of B vector cross A vector we have to prove. Okay. So listen. So I am taking LHS. Okay, left hand side. LHS equal to A vector plus B vector cross A vector minus B vector. Okay. So that's equal to A vector cross A vector. A vector cross A vector plus this plus A vector, sorry, plus into minus, minus. Okay, A vector cross B vector. Okay, then this B vector cross A vector plus B vector cross A vector. Then B vector cross B vector, that is minus B vector cross B vector. So that's equal to, what is A vector cross A vector? That is equal to 0. Okay, I vector I cap cross I cap is equal to 0. A vector cross A vector is equal to 0 because the angle between the two vectors is equal to 0. So cross product that is A vector cross B vector is equal to AB sin theta into n cap. So theta is the angle between the two vectors. So two vectors means parallel means or anti-parallel. Theta is equal to 0 or theta is equal to 180 degree. So the cross product is equal to 0. So here A vector cross A vector. What is the angle between? This is A vector. This is also A vector. Okay, A vector. Same vectors. So the angle between these two vectors is 0. So A vector is acting in this line direction. Another A vector is also here. So the theta is equal to 0. So we can write A vector cross A vector 0 minus. Okay, minus of. I am writing that is A vector cross B vector. A vector cross B vector is equal to minus of B vector cross A vector. That is anti-parallel. If the two vectors are, no, that is anti-commutative. Anti-commutative rule we have studied. A vector cross B vector is equal to minus of B vector cross A vector. Okay, B vector cross A vector. So I am writing this A vector cross B vector minus B vector cross A vector plus B vector cross A vector minus, what is B vector cross B vector? Again 0. Okay, so 0. So that's equal to minus of minus plus B vector cross A vector plus B vector cross A vector. Okay, so that's equal to 2 times of B vector cross A vector plus B vector cross A vector. That is 2 times of B vector cross A vector. So what is, we have to prove 2 times of B vector cross A vector. Kadam. Clear? So the next question, 8th question. Oh, so this is 8th question. So next question is 9th question. Okay, 9th question. So 10 questions we have to solve. That is dot product, cross product of vectors. Okay, cross product of vectors. So in the previous section we have discussed the concepts of cross product of vectors. So 10 numericals we have to solve. So question number 9. Question number 9. If A vector comma B vector comma C vector are mutually mutually perpendicular. Mutually perpendicular. Show that. Okay, show that C vector cross A vector cross B vector is equal to 0 is the converse is the converse true? Is the converse true? So this question is from H.C. Verma. Okay, H.C. Verma. So A vector, B vector, C vector are mutually perpendicular. Show that C vector cross A vector cross B vector is equal to 0. Is the converse true? Okay, is the converse true? So here, this is A vector. Okay. So this is B vector and this is C vector. So these three vectors are mutually perpendicular vectors. Okay. So what is the direction of, first in the bracket, A vector cross B vector. So what is the direction of the resultant vector of A vector cross B vector? Okay, A vector cross B vector. See, these are the three vectors. Okay, three vectors. Perpendicular, right? Perpendicular. Then the third vector is also perpendicular. Mutually perpendicular. Okay, mutually perpendicular. It is like this. A vector, B vector, C vector. Okay. So this C vector is like this. Actually, A vector, B vector. This is the plane. Okay. This board is the plane which contains three vectors. A vector, B vector. So the direction of the C vector is like this. So this is the direction of the C vector. The C vector is acting outwards from the board. Okay. So that vector we have shown like this, C vector. Okay, C vector. So this means it is acting like this. Okay. So A vector, B vector and C vector. So what is the resultant? Right hand thumb rule. So from A vector to B vector. So A vector, B vector. So we are finding that is A vector cross B vector. A vector cross B vector. So from curl your fingers of your right hand from A vector to B vector. So A vector to B vector. So what is the direction of the thumb? Thumb is also in this direction. Am I right? Thumb is also in the direction of C vector. C vector. Suppose I am getting that is A vector cross B vector. It is a vector only. I am taking this vector, that is R vector. Okay, R vector. Okay, R vector. Next we have to find that is C vector cross R vector. So from this right hand thumb rule, A vector cross B vector. So, okay, so from right hand thumb rule, so the resultant vector is in this direction, So it is nothing but along the C vector. Now what is the angle between, that is C vector cross R vector. So this is the R vector. Right? So these two vectors are parallel. Okay, two vectors are parallel. So what is the angle between these two? C vector and R vector is equal to 0. So C vector cross R vector. Come on. C vector cross R vector is equal to modulus of C vector, modulus of R vector, sin theta into n cap. So what is the theta? Is the angle between these two vectors. What is the angle between these two vectors? That is 0. Sin 0 is equal to 0. So therefore C vector cross R vector is equal to 0. Therefore we are getting that is A vector cross C vector cross A vector cross B vector is equal to 0. Right? So what is asked in the converse, is the converse true? Converse true means C vector, 3 vectors are there. Okay, A vector, B vector and C vector. 3 vectors are there. So their cross product, that is C vector cross A vector cross B vector is equal to 0. Is equal to 0. It is given. Now, is C vector cross A vector cross B vector is equal to 0. So that is these 3 vectors, that is A vector, B vector, C vector, necessarily be perpendicular. Necessarily be perpendicular. Or would these 3 vectors will be perpendicular? Perpendicular. So this we can prove. This condition is given. That is C vector cross A vector cross B vector is equal to 0. Will these 3 vectors necessarily be perpendicular? Perpendicular. Let us take. Suppose this is A vector. So the B vector is not perpendicular to A vector. So it is in this direction. In this direction. So 60 degree. 60 degree. Theta. So first we have to find that is A vector cross B vector. So this is B vector. This is B vector. A vector cross B vector. A vector cross B vector. So the resultant, what is the direction of the resultant? It is outward from the board. Outward from the board. Outward from the board means it is same in this direction. Okay, same in this direction. So R is the resultant vector. Okay, in this case also R is the resultant vector. So R vector is along the C vector. So I will show you these 3 vectors. Okay. So here this is A vector and this is B vector, not perpendicular. So it is like this, some 60 degree. Okay, 60 degree. So C vector is perpendicular like this, perpendicular. Okay. So what is A vector cross B vector? Curl your finger, right hand thumb rule. Curl your fingers from A vector to B vector. So the thumb is acting in this direction. So C vector is in this direction. So thumb and this vector, C vector, are parallel. So here A vector cross B vector, we are getting one vector. Okay, that is R vector. R vector, C vector cross R vector. So they are in the same direction. What is the angle between this C vector and R vector? Is equal to 0. Theta is equal to 0. So we are getting C vector cross R vector is equal to 0. So that's why we are getting C vector cross A vector cross B vector is equal to 0. But in this case, these 3 vectors are not mutually perpendicular. Okay. So this vector, the angle between A vector and B vector is 60 degree. The angle between B vector and C vector is not 90 degree. They are not mutually perpendicular. Okay, mutually perpendicular. This condition is given. Okay, these conditions we can prove in this case also. But the vectors are not mutually perpendicular. So is the converse is true? No. No, the converse is converse is not true. Not true. Acha. Understand? So concept. Okay. Then 10th question. Question 10. The magnitude of scalar and vector products. The magnitudes of scalar and vector products scalar products or scalar products of two vectors are 48 root 3 and 144 respectively. What is the angle between the two vectors? What is the angle between the two vectors? So suppose A vector and B vector are two vectors. The magnitude of the dot product is given. The magnitude of the cross product is given. Magnitude of the dot product is 48 root 3 and magnitude of the cross product is 144. So we have to find the angle between the two vectors, A vector and B vector. Suppose A vector and B vector. So consider, so this is a A vector. Understand? This is B vector. So these are inclined at an angle theta. Inclined at an angle theta. So their dot product, magnitude of the dot product is given. Magnitude of the cross product is given. So we have to find this angle theta we have to find. Okay. So that is the magnitude of scalar product. What is magnitude of scalar product? That is A vector dot B vector. Scalar product is equal to what is given, that is 48 root 3. Magnitude of cross product A vector cross B vector is equal to, that is 144. What is A vector? A vector dot B vector, AB cos theta is equal to 48 root 3. Take it as equation number 1. What is A vector cross B vector? That is AB sin theta is equal to 144. Take it as equation number 2. Okay. So 2 divided by 1 implies, that is AB sin theta divided by AB cos theta is equal to 144 divided by 48 root 3. Okay, 48 root 3. So AB cancel. Sin theta by cos theta, tan theta. Okay, here I am cancelling with 12. That is 12 12s are 144. 4 times 12. 4 12s are 48. Okay, 4 12s are 48. So 4, that is 3. So 3 divided by root 3. Okay, 3 divided by root 3. So 3 we can write what, that is root 3 into root 3. Okay, so this root 3 cancel. Okay, sin theta by cos theta, tan theta. Tan theta is equal to root 3. Tan theta is equal to root 3. So theta is equal to 60 degrees, standard angle. So theta is equal to 60 degree. Understand? So with this we complete that this 10 numericals in the cross products. So in the previous section we have discussed the cross products of the concepts of cross product, and in this section we have solved that is 10 numericals. Go through it, go through the concept to try to solve more problems. That is then the concept will be very clear. So very important concept, that is dot product and the cross product, that is throughout physics we are applying. So this dot product and the cross product we are applying in physics. In physics also so many quantities are there. That is by applying this dot product and the cross product, so many quantities are there. Okay, so in the next section we will meet with, that is projectile motion. Okay, projectile motion, the concepts of projectile motion. Thank you.